In this video, we are going to solve problem based on Coulomb's law. Let us start with question 1.44. A negative 4 microcoulomb charge lies 20 centimeter to the right of a 2 microcoulomb charge on the x-axis. What is the force on the 2 microcoulomb charge? So here you have a negative 4 microcoulomb charge which is lying to the right of 2 microcoulomb. So if I draw the 2 microcoulomb charge here and we call it Q1, you have the negative 4 microcoulomb charge lying to the right of it. We will call this Q2, and the distance between them is 20 centimeter, which we call it as R. We need to find what is the force on charge Q1. So let's write down the magnitude of these charges. Q1 is 2 microcoulomb. The power of micro is 10 to the power negative 6. Q2 is negative 4 microcoulomb. So we rewrite this as negative 4 times 10 to the power negative 6 Coulomb. And the distance between them is R, which is 20 centimeter. We divide this by 100 to write the distance in meter. So you get this as 0.2 meter. And we need to find the electrostatic force between them. Now force on charge 1 because of charge 2 can be written as F because of 2 on charge 1 to be equal to K Q1 Q2 over R squared, where K is the Coulomb's constant and the magnitude of K is 8.99 times 10 to the power 9 Newton meter squared per Coulomb squared. Q1 and Q2, we have to take their absolute value when we are finding the magnitude of force. We don't need to substitute the sign here. So let's calculate the force. I will write the expression as K equals 8.99 times 10 to the power 9. Q1 is 2 microcoulomb. Q2 is 4 microcoulomb. We are not going to take the sign here since we are calculating the magnitude of the force divided by the distance squared, so 0.20 squared. And when you solve this, you get the force as 1.798 Newton, which you can round off to 1.8 Newton. Now, direction of this force you can find by looking how the charges interact with each other. We are finding the force on Q1. Now, Q1 is a positive charge, Q2 is a negative charge. So because of Q2, Q1 will move to the right as it is attracted to Q2. So direction of force will be to the right. So I can write my force F because of 2 on 1 to be equal to 1.8 Newton X cap, or you can just write here 1.8 Newton to the right. Question 1.38. Two charged spheres are 8 centimeter apart. They are moved closer to each other enough that the force on each of them increases 4 times. How far apart are they now? So here in this question, you have two charged spheres. Let us call them sphere 1 and sphere 2. Initially, they are 8 centimeter apart. We call this distance between them as R1. And when they are brought closer to each other, let's say the distance now is R2, the force between them increases 4 times. So if we took the force between them initially to be F1, in the second scenario, we will take that force to be F2 when they are brought close to each other. And the question says that F2 is 4 times F1. So when I take a ratio of F2 over F1, I get as 4. Then my R1, the distance between the sphere initially is 8 centimeter. I need to find how far apart are they later when they are brought close to each other. Let the charge on the sphere 1 be Q1, while that on sphere 2 be Q2. In the initial position when the spheres are 8 centimeter apart, we can write the force between them as F1 to be equal to K Q1 Q2 over R1 squared. And when they are brought closer together, we can write the new force F2 again as K Q1 Q2 over R2 squared, where R2 is the new distance between them. Let's take a ratio of these two forces. I will write F2 over F1 equals, substitute that, K Q1 Q2 over R2 squared upon, now we write for F1, K Q1 Q2 over R1 squared. Now we can cancel off the common terms here. K Q1 Q2 is the same for both, so we can just cancel this off. And then we can rewrite this ratio as F2 over F1 equals R1 squared over R2 squared. We already know that F2 over F1 is 4. So I can substitute that here. 4 equals R1 squared over R2 squared. I need to find what is R2. So in order to find R2, I will first take square root on both sides. And when you do that, you get square root of 4 as 2 equals R1 squared. When you take the square root, will become R1 over R2. Now we cross multiply to calculate R2. I will take R2 here in place of 2 and bring the 2 down. So we get R2 as R1 over 2. R1 is 8 centimeter. So we substitute 8 divided by 2. That gives me my R2 as 4 centimeter. So when the force increases by 4 times, the distance will decrease by half. Initially, my distance was 8 centimeter. It reduced by half and became 4 centimeter. Question 1.39. Two identically charged particles separated by a distance of 1 meter repel each other with a force of 1 Newton. What is the magnitude of the charges? So let us write down what is given to us. I have two identically charged particles. That means Q1 has to be equal to Q2, and we will write them both as just Q. The distance between them R is 1 meter, and they repel each other with a force F of 1 Newton. I need to find what is the magnitude of the charge. I need to find what is the value of Q. Electrostatic force between two charged particles F is given as K Q1 Q2 over R squared. Now these two charged particles are identical. That means they have the same charge. So if I write Q1 as Q and Q2 as Q and multiply them together, we get F as K Q squared over R squared. I need to find what is Q. So you can directly substitute all the values at this point here and use shift solve. Or you can rearrange the term to write in terms of Q and then substitute the values. So let's rearrange them. So we move R squared to the top here and bring K at the bottom. And we can rewrite this expression as FR squared over K equals Q squared. I want to find Q and not Q squared, so take square root on both sides. You get Q equals square root FR squared over K. Now substitute the values. F is 1 Newton, R is 1 meter, K is 8.99 times 10 to the power 9. And when you solve this, you get the value of U as 1.05 times 10 to the power negative 5 Coulomb. Now, while solving questions, you can also take the value of K as just 9 times 10 to the power 9 instead of 8.99. Question 1.40. How far apart must two electrons be placed on Earth's surface for there to be an electrostatic force between them equal to the weight of one of the electrons? So here in this question, we have two electrons. Since they are both electrons, charge on them will be equal. So I can write Q1 to be equal to Q2, which will be equal to the charge of the electron, which is the elementary charge E. I'm not taking the negative sign here because when we are calculating the magnitude of electrostatic force, we don't need to put the sign there. So I will just keep the charge on the electron as E, which is the elementary charge, and it is a constant that is equal to 1.602 times 10 to the power negative 19 Coulomb. So we need to find how far apart they are such that the electrostatic force between them is equal to the weight of one of the electron. So my electrostatic force has to be equal to the weight of the electron. Weight of an object is the gravitational force acting on that object, that is equal to m times g, mass of the object times the acceleration due to gravity. So I can write the electrostatic force here to be equal to mass of the electrons times g. So let's calculate the distance r. We will write the force F as F equals K Q1 Q2 over R squared. Both Q1 Q2 I will write as E. So when you multiply E with E, you get E squared. So F equals K E squared over R squared. Again, you can use shift solve directly at this step to calculate the value of R if you do not wish to rearrange. We will rearrange the terms here. I will move R squared on the top. F will come down here. We just cross multiply them. Then I rewrite my expression as R squared equals K E squared over F. We need to calculate R, so take square root on both sides, and then we write R equals square root K E squared over F. After rearranging the terms, we can substitute for F here. F is mass of the electrons times acceleration due to gravity. Now we can plug in the numbers. R equals square root. K is 8.99 times 10 to the power 9 times electron 1.602 times 10 to the power negative 19 squared over mass of the electron is a constant again. And the value of that constant is ME equals 9.11 times 10 to the power negative 31 kilogram. So we substitute that here, 9.11 times 10 to the power negative 31. G is 9.81. And when you solve this, you get the value of R as 5.08 meter. So this is how far apart the electrons must be from one another so that the electrostatic force between them is equal to weight of one of the electrons.